Welcome back to the deep dive. Get ready, because today we're plunging into something that's, well, it's more than just a buzzword. It's a really profound shift happening right now in tech. We're talking about agentic AI.
That's right. Think of it like AI taking its next big evolutionary step. So instead of just, reacting to prompts or spitting out text or images.
Right, like generative AI.
Exactly. These new systems can actually perceive their environment. They can reason about what needs doing, make plans autonomously. And then this is the key part. Act on those plans to achieve a bigger goal.
Okay, perceiving, reasoning, planning, acting. And to help us really get a handle on this leap, we've gathered some great sources. We've got a comprehensive expert overview on agentic AI, plus some really fresh market reports, literally just out this month, May 2025.
Yeah, and our mission today is pretty straightforward. We want to unpack what agentic AI actually is, look at how these systems are built, what's going on under the hood, and show you where they're already being used, like right now. And also lay out the critical opportunities, but also the tough challenges they bring.
So the goal is simple.
Yeah.
You walk away really well informed about this field because it's moving incredibly fast.
Absolutely. This isn't science fiction anymore. I mean, it's being built, it's being deployed as we speak, poised for huge adoption.
So let's dive in.
Okay, so let's start with that core shift. What's really fascinating, I think, is this move away from AI that's basically waiting for instructions, waiting for a prompt.
Passive almost.
Yeah, passive is a good word. To systems that have an objective, a goal, and they figure out how to get there pretty much by themselves. They look at the situation, weigh their options, and decide the path forward without needing a human holding their hand every single step.
Okay, so it's really about having that goal and then figuring out the how itself,
Oh,
autonomously.
exactly. That autonomy is absolutely key. The ability to kick off tasks, make decisions independently. It also means they have goal-oriented behavior. They can break down big objectives into smaller steps and adjust their strategy if things change.
Adjust on the fly.
And crucially, they have self-learning and adaptability built in. They get better over time. They learn from experience using things like reinforcement learning, feedback loops.
So you're saying they're not just running a fixed program, they actually learn and improve as they interact with the world.
Precisely. And to do that, they need context awareness, understanding the situation they're in. They need reasoning for planning, for reflecting on what worked or didn't. And then critically, they need to take action executing tasks strategically to hit that goal.
That ability to act strategically towards a goal, that feels like a really big departure. How is this different from, the AI we've gotten used to?
Well, if you compare it to the older stuff, traditional AI, the rule-based systems, they were very rigid. You hit an exception, they often just stopped. Agentic AI moves way beyond that. It can handle the messiness, the variability of the real world. It's much more flexible.
Okay, more adaptable than rule-based. What about standard machine learning?
Traditional ML is fantastic at finding patterns, making predictions from data. Agentic AI takes that predictive power, but combines it with the flexibility and the sort of language understanding we see in large language models, LLMs.
Ah, okay. So it's merging that statistical power with language smarts.
Right. It's about combining that ML precision with LLM adaptability.
And how do those big LLMs, the ones everyone's talking about, fit into this agentic AI picture?
Yeah, LLMs are amazing for understanding and generating language, right? Fantastic content creators. So the agentic AI is fundamentally about action. It's goal-driven.
So the agent uses the LLM.
Exactly. The agent kind of directs the LLM. It decides when to call on the LLM's abilities, maybe for analysis or communication, and how to use that output to move closer to its goal. One source used a great analogy. The LLM is often the brain.
Providing the reasoning, the language bit.
Right, but the agent is the orchestrator. It's the one crafting the plan, executing the steps, using the LLM as a powerful tool in its toolbox.
Got it. So the agent is like the conductor of an orchestra, and the LLM is maybe the star violinist, but still needs direction.
That's a perfect way to put it, yeah. And it highlights that agentic AI is really acting as a kind of metasystem, coordinating different AI capabilities. And that constant loop learning, self-correcting based on feedback, that iterative refinement, the sources really hammer this home. It's not just a nice-to-have feature. It's fundamental. It's how they manage to operate effectively in dynamic, changing environments.
Okay, that makes total sense. It's not just hitting the target, but the whole process of figuring out the path, adapting along the way.
Right.
That's baked right in.
Exactly. Now, if we dig a bit into the theory behind all this, agentic AI isn't entirely new conceptually. It draws heavily from classic AI theory and also from cognitive science. It's really about trying to build systems that mimic more complex human cognitive processes.
Like trying to model how we think and make decisions.
Precisely. And one really key framework here, something that's found renewed relevance with the rise of LMs, is called the Belief, Desire, Intention Model, BDI for short.
BDA.
It was originally developed way back for intelligent agents, and it's designed specifically to mirror how humans seem to make decisions and plan actions.
Belief, desire, intention. Let's break that down a bit. What do those mean in this AI context?
Okay, so beliefs. Think of those as the agent's knowledge or understanding with the world, about itself, other agents, the environment. And the term belief is used deliberately because this information might not be perfect or complete, right?
Okay, like our own beliefs, sometimes wrong.
Exactly. Then desires are the potential objectives, the things the agent could want to achieve. Goals are the specific desires the agent has actually committed to pursuing. And these goals need to be consistent. An agent can't have active goals that directly contradict each other.
Right, makes sense. So goals are the desires it actually decides to act on.
Yes. And intentions are the specific plans the agent has chosen and is actively executing to achieve those goals. Plans themselves are like recipes, sequences of actions. And events are triggers, things happening externally or internally that might make the agent update its beliefs or, rethink its current plan.
What's really interesting here, based on the sources, is how this structured BDI model kind of helps bring order to the, well, sometimes fuzzy nature of LLMs.
Absolutely. LLMs are incredibly powerful, but they can sometimes struggle with things like maintaining a consistent state over a long interaction, or remembering what they just did, or planning complex multi-step tasks.
Right, the memory issue.
Yeah. The BDI model provides that crucial structure. The beliefs give it a form of persistent memory, a knowledge base. The desires and goals provide clear objectives. And the intentions and plans give it a framework for sequences of actions. It's a way to guide the very fluid, probabilistic outputs of an LLM towards structured, goal-directed behavior.
So it provides the scaffolding.
Yeah.
Or maybe the operating system for the LLM's more flexible brain.
That's a really good way to visualize it. Yeah. And as you touch on, the influence from cognitive psychology is clear. It's this push beyond just pattern recognition towards systems that embody higher-level cognitive functions, perception, decision-making, planning, the works.
Okay, so shifting from the theory to actually building these things, especially for big organizations, for enterprise use, the sources seem to say certain architectural principles are, well, non-negotiable.
Definitely, especially for what you might call enterprise-grade agentic AI. 3 things pop up consistently: modularity, scalability, and interoperability.
Okay, modularity first.
Modularity means building the system from distinct, often specialized components. This makes development way easier. Debugging is simpler because you can isolate problems in one module, and you can update or swap out parts without wrecking the whole system.
Makes sense. And scalability. Seems obvious for enterprise.
Absolutely essential. Enterprise systems deal with huge amounts of data, growing complexity. You deploy more agents, tackle bigger problems. The architecture just has to scale smoothly without falling over.
What about interoperability? Why is that one non-negotiable?
Because these agents don't exist in a bubble, right? They need to work seamlessly with all the existing software, databases, APIs, tools that a company already uses. Interoperability is critical to actually integrate these agents into real business processes, not just have them as standalone curiosities.
Right, they need to plug into the existing machinery.
Precisely. These principles are really the foundation for building robust, maintainable, and actually deployable agentic systems in the real world.
So, based on those principles, how do these agents actually, perceive the world and decide what to do next? What do the architectures look like?
Yeah, so there are different flavors of agent architecture. The main types discussed are reactive, deliberative, and hybrid.
Reactive sounds fast.
It is. Reactive agents are the simplest. They have a direct perception action loop. They basically just react instantly to whatever they sense right now. Think of a basic guard character in a video game sees player, immediately attacks or runs. Very little memory or planning involved.
Quick reactions, but maybe not much strategy.
Exactly. Deliberative agents are kind of the opposite. They maintain internal models of the world, they plan ahead, they reason about the consequences of actions, they follow more of a perception decision action loop, much more goal-oriented, but they generally need more time and computational power.
Okay, slower but smarter, maybe.
Potentially, yes. The sources also mention utility-based agents as a type of deliberative agent where they explicitly weigh different options based on their expected outcome or utility.
And hybrid agents. Best of both worlds.
That's the goal. They try to combine the speed and responsiveness of reactive systems with the longer-term planning and reasoning of deliberative systems. And this is really crucial for most complex real-world tasks. You often need to react quickly to unexpected things.
Like a self-driving car needing to brake suddenly.
Right. While also maintaining progress towards a longer-term goal, like navigating to a destination. Most practical agents end up being some kind of hybrid.
And this is where those LLMs slot back in, presumably. That's part of the decision part.
Absolutely pivotal. Like we said, they often serve as the brain, providing the reasoning horsepower, the language understanding, sometimes even generating potential plans in natural language that the agent framework then interprets and executes.
The agent framework orchestrates when to tap into the LLM and what to do with its output.
Exactly.
What about multimodal AI? That ability to process text, images, audio all together. How important is that?
The sources frame this as a fundamental step towards more human-like understanding. Think about how we understand the world. We combine sight, sound, reading, all simultaneously. For an agent to truly grasp a complex situation, say, understanding a patient's condition from their medical history text, maybe MRI scans images, and the doctor's dictated notes, audio. It needs that multimodal capability. It's key for richer context.
LLMs aren't perfect.
Right.
We hear about hallucinations, inconsistencies.
Yeah.
The agent architecture needs to manage that.
Yes, absolutely. That's a critical challenge. LLMs are probabilistic, meaning their output isn't always guaranteed to be correct or consistent. They can, as you said, hallucinate, make things up. They can struggle with maintaining context over long interactions. And just debugging a system that uses an LLM can be tricky because it's not deterministic.
So the agent needs safeguards.
Definitely. The overall agentic system needs robust feedback loops, error checking, maybe mechanisms to verify the LLM's output or cross-reference it against other sources. Especially for critical tasks in an enterprise setting, you need reliability.
So the agent acts like a supervisor for the LLM brain, keeping it on track.
That's a good way to think about it. Which leads us nicely into how agents structure their knowledge and plan their actions. Two key technologies here are knowledge graphs and advanced planning algorithms.
Okay, planning first. How do agents figure out the steps?
Planning algorithms are essentially how agents systematically explore possible sequences of actions to get from their current situation to their desired goal state. It's vital for efficiency, making sure they don't just wander randomly.
Like finding the best route on Google Maps.
Exactly, that kind of idea. The sources mention various algorithms from classic search methods like breadth-first search or A that explore options systematically to more modern approaches using probability or reinforcement learning, which are better suited for environments that are dynamic or uncertain.
And knowledge graphs, or KDs. What's their role?
Knowledge graphs are structured ways of representing information. Think of them as networks of entities, people, places, products, concepts, and the relationships between them, like a detailed, interconnected map of the agent's domain.
And why are they so important for agentic AI?
The sources really emphasize their role as a system of truth. They provide grounded context for the agent's reasoning. They allow the agent to make logical inferences based on the structured relationships. And critically, they are essential for explainability and transparency.
Explainability. You mean understanding why the agent made a certain decision?
Yes. A huge benefit of KGs is that you can potentially trace each prediction or decision back to its source within the graph structure. This is vital for building trust, for debugging, and for compliance in regulated fields. They provide a structured, verifiable foundation that nicely complements the more fluid, sometimes opaque nature of LLMs.
And there's a learning connection too. Agents can update the KG.
Right. As an agent interacts with the world or processes new information, it can potentially update the knowledge graph, adding new facts or relationships. This creates kind of self-reinforcing loop where the system's knowledge base improves over time.
So it's like a convergence. Symbolic AI like KGs in planning, meeting connectionist AI like LLMs.
That seems to be the direction. That combination appears necessary for building more robust, more generally capable intelligence.
We also mentioned reinforcement learning, RL, earlier. How does that fit into the learning picture?
RL is absolutely fundamental for how these agents learn through interaction. It's basically learning by doing trying actions, interacting with the environment, or using tools, getting feedback, rewards or penalties, and adjusting strategy accordingly. It's the engine driving that continuous adaptation and self-correction we talked about.
And one source had that really intriguing idea about RL maybe solving a big LLM problem.
Yes, that definitely stood out. The idea that RL could potentially offer a way around the looming problem of LLMs running out of training data, if agents can learn and generate new, useful training states directly from their own behavior and feedback while operating in the real world at inference time.
They could essentially create their own ongoing training data.
Potentially, yes. It could be a path towards self-sustaining learning systems that continue to improve long after their initial pre-training phase. That's a very powerful, though still speculative, concept for the future of AI development.
Wow, that really pushes the boundaries.
Yeah.
Okay, so let's get practical. What tools are developers actually using now to build these agent systems? Are there frameworks?
Oh, yes. Open source is huge here. It's really democratizing development and speeding things up. Several key frameworks get mentioned. LangGraph, for example, which comes from LangChain.
I've heard of LangChain.
Right. LangGraph lets you model complex workflows, especially involving multiple agents, as stateful graphs. It's very flexible, good for handling intricate logic and maintaining state over long processes.
Yeah.
You see it used a lot by SaaS startups or companies building really complex custom agentic features. The downside is it can be a bit more resource intensive.
Okay. What about Microsoft AutoGen?
AutoGen is focused heavily on enabling collaboration and conversation between multiple agents. It's known for being quite flexible and relatively easy to get started with. It's particularly strong if you're already deep in the Microsoft ecosystem, and seems well suited for automating workflows where clear communication protocols between agents are needed.
And there was another one, Crew AI.
Yeah, Crew AI is specifically designed for orchestrating teams or crews of specialized agents that need to work together on a common task. It offers both code and no-code interfaces, aiming for faster deployment. It seems popular for things like marketing campaign generation, research tasks, maybe more for mid-sized businesses needing coordinated AI assistance without super customization.
So if you're an organization looking to jump in, you've got a strategic choice to make about which framework fits best.
Absolutely. It's that classic trade-off. How much customization do you need versus how important is ease of use or leveraging a standardized platform? And interestingly, the sources note this is even starting to shake up business models. We might see a shift away from just paying for API calls towards per task, or even value-based pricing for what these agent services actually accomplish.
That's a significant shift. Okay, let's talk applications. Where are we seeing these agentic AI workflows actually making a difference today?
Right. So an agentic workflow, it's essentially an AI-driven process that handles complex, multi-step tasks autonomously and crucially adapts dynamically as things change. This goes way beyond traditional robotic process automation, RPA.
How so? RPA automates tasks too.
It does, but RPA is typically very rigid. It follows a predefined script. If the website layout changes slightly, the RPA bot often breaks. Agentic AI is designed to be more robust, to understand the goal and figure out how to achieve it, even if the exact steps change.
Got it. More adaptable. And a key part of this is having multiple agents work together.
Yes, multi-agent orchestration. Coordinating specialized agents, sometimes called agent swarms, to tackle goals that are too big or complex for just one agent. This involves things like having a central controller or coordinator, clear communication channels between agents, and ways to manage shared resources.
Like a digital project team.
Kind of, yeah. And the sources bring up something interesting here. Emergent behavior.
Emergent behavior. What's that?
It's when complex, often unexpected system-level patterns arise from the interactions of many simple agents just following their own local rules. The classic example is a phantom traffic jam congestion that appears on a highway for no obvious reason, like an accident, but just emerges from the collective braking and acceleration decisions of many individual drivers.
Huh. So complex results from simple interactions sounds powerful, but maybe also unpredictable.
It can be both. Harnessing emergence is powerful, but debugging unexpected emergent behavior can be really challenging. It's one of the complexities of multi-agent systems.
Okay, so where are these systems actually being applied? This is where it gets really interesting, right?
Absolutely. The range of applications mentioned in the sources is surprisingly broad already. In software development and IT, for instance, agents are helping with generating code, reviewing code for bugs or style issues, automating complex testing scenarios. GitLab was mentioned using an agent for predictive code completion, helping developers write code faster.
So developers are getting these AI pair programmers.
Pretty much, yeah. Customer service is another huge area. Agents are providing personalized support 24/7. They can handle initial questions, triage issues to the right department or human, and do what's called a smart handover, providing the human agent with all the context when escalation is needed.
And there was a striking statistic about customer service.
Yes, a projection from Cisco Research, cited as May 2025, they forecast that Agentic AI could be handling a massive 68% of all customer service interactions by 2028.
Wow, 68% in just 3 years. That number really underlines the expected speed and scale of adoption.
It really does. And related to that, 93% of survey respondents in that research anticipate service becoming more personalized and proactive thanks to these agents.
Okay, besides code and customer service.
Financial services is another big one. Agents are being used for things like complex risk audits, ensuring compliance with financial regulations, assisting in loan underwriting processes, and even providing initial analysis for financial advisors or wealth managers. Tasks that involve a lot of data and adapting to changing market conditions.
Makes sense. Data heavy, rules based, but needs adaptation.
Right. Scientific research and R&D is also a fascinating area. Agents are being used to accelerate discovery. They can sift through mountains of research papers, synthesize findings, identify potential connections or contradictions that a human might miss, even help formulate new hypotheses.
So helping scientists connect the dots faster.
Exactly. Microsoft Discovery was mentioned using agents and knowledge graphs for materials science. Clarivate also has a platform using AI for researchers helping synthesize literature, find collaborators, identify relevant funding opportunities.
What about some of the newer or more niche areas mentioned?
We're seeing applications pop up across the board. Agriculture, Blue River Technology, now part of John Deere, was cited for using autonomous robotics, essentially agents, for precision weed spraying. Content creation agents autonomously generating draft articles, marketing copy, even visual designs. Gaming creating much more believable, human-like, non-player characters, NPCs. The Stanford AI Village simulation was a notable example there.
NPCs that actually seem like they have goals.
Exactly. Cybersecurity is another key area, agents enhancing threat detection, analyzing alerts, and automating initial response actions. Companies like DropZone AI and Radiant Security were mentioned. Also seeing uses in HR for tasks like initial resume screening or personalized onboarding, and in retail commerce for sophisticated recommendation engines and automating back-end processes.
It really does sound like a horizontal technology, something that can be applied almost anywhere there's a complex process.
It really is. And a consistent theme running through almost all these examples is augmentation, not just replacement. Agentic AI is often positioned as enhancing human performance, freeing people from repetitive or data-intensive parts of their jobs so they can focus on higher-value activities, strategic thinking, complex problem-solving, human interaction.
Like the AI copilot idea again.
Exactly.
Yeah.
The AI handles the initial coding draft, the human refines it, the AI handles routine customer queries, the human tackles the complex, emotional ones. The sources often frame this using phrases like, creating valuable digital contributors that work alongside human teams.
Valuable digital contributors. I like that framing. It suggests a new kind of colleague, almost.
Yeah.
So how do humans and these digital contributors actually work together effectively? That interaction seems crucial.
It's absolutely critical, and it's a major focus of research and design. It boils down to collaboration, effective oversight, and building trust. Agents need to be designed to understand human intent, not just explicit commands, and importantly, incorporate human feedback to improve or correct course.
What are some of the main challenges in getting that collaboration right?
Well, communication is a big one. Agents, even with powerful LLMs, can still struggle with understanding nuanced context or subtle human cues. And humans, interestingly, tend to mentalize AI. We attribute intentions and understanding, sometimes more than is actually there. So achieving what the researchers call a co-construction of understanding, where both the human and the agent are truly on the same page about the task and the process, is really important, but not always easy.
And current agents have limitations, right?
Definitely. They generally lack genuine empathy. They can struggle with truly creative, outside-the-box thinking. They might follow instructions literally, even when common sense suggests otherwise.
Which explains why strategies like careful task triaging, deciding what's suitable for an agent, having human supervisors available, and designing those smart handover mechanisms are so emphasized in the sources.
Exactly. The reports are quite clear that most current systems are best described as semi-autonomous. They absolutely require human-in-the-loop design for safety and effectiveness. And to build that necessary trust, transparency is key. That idea of explainable AI, XAI, so you can understand why an agent did something. Plus, you need robust governance frameworks and clear structures for accountability.
Okay, let's zoom in on the current landscape. It's May 2025 now. What's the state of play, both in research labs and out in the market?
The pace is just incredible. On the academic side, research is buzzing. People are pushing hard on improving agent reasoning abilities, enabling better self-reflection or self-critique in agents, developing more sophisticated ways for multiple agents to coordinate and negotiate.
And tackling those core problems we mentioned.
Yes, directly addressing things like the context window limitations of LLMs, trying to make agent behavior less brittle, more consistent, tackling that hallucinating intern problem where an agent sounds plausible but is confidently wrong. There was even a fascinating pilot program mentioned at a major AI conference, ICLR 2025, using an AI agent to help assess the quality of peer reviews submitted by humans.
Using AI to help check AI research quality. Interesting. And what about the commercial side?
It's just explosive growth and intense competition. The projections and the market reports are really eye-opening. Gartner, for example, forecasts that by 2028, agentic AI capabilities will be integrated into about a third, 33% of enterprise software applications. And they predict autonomous agents could be involved in making around 15% of common business decisions by then.
15% of decisions
Yeah.
autonomously.
That's the forecast. And Future Research put out a number suggesting the global economic value generated by agentic AI could hit something like $6 trillion by 2028. Even looking back slightly, a LangChain survey from 2024 indicated over half of developers using their platform are already incorporating agents into their daily workflows.
Those are staggering numbers. They really point to rapid, widespread adoption. Who are some of the key players rolling out platforms and services right now?
We're seeing major platforms emerge very quickly. Mistral AI, for instance, launched an Agents API with built-in tool connectors. Snyk has an AI trust platform focused specifically on security agents and governance around AI use. DataRobot released an open-source framework called Siftar. OpenAI's Codex capabilities are foundational for many coding agents. Amazon has AWS Transform for .NET, using AI agents for things like application modernization. Anthropic enhanced its API with new features explicitly supporting agentic workflows.
And the sources called out some specific performance metrics or standout features.
Yes, those were quite notable. Salesforce's Agentforce platform got a perfect 10/10 performance rating in one report from Future Research, with users apparently reporting seeing return on investment in just a couple of weeks sometimes.
ROI in weeks, that's fast.
Very fast. IBM's watsonx Agents platform was highlighted for its leadership specifically in governance, also scoring 10/10 in that area. Things like built-in compliance, auditing features, explainability safeguards, really targeting those core enterprise needs. And Microsoft's Copilot agents were reported to be achieving significant reductions in customer service response times.
That rapid ROI and the strong focus on governance and explainability, those really seem like crucial signals for driving enterprise adoption, don't they?
Absolutely. And you see influential labs and figures pushing this forward. Microsoft Research, alongside labs like PNNL, are doing work on using agents for scientific discovery, like finding new materials. Clarivate, as mentioned, is applying agents specifically to academic research workflows. You have academics like Professor Nilufar Salehi at UC Berkeley who are really championing a human-centered approach, focusing on reliability, transparency, memory, human control.
So pushing for responsible development alongside capability.
Exactly. Then you have market analysts like Dion Hinchcliffe and Nick Jones providing critical insights into how enterprises are actually adopting this, the trends, the challenges, and figures like Salesforce CEO Mark Benioff framing agents very explicitly as representing a fundamental shift, a new labor model, new productivity model, and a new economic model.
It really sounds like a dynamic feedback loop. Academic research pushes the frontier, industry rapidly builds and deploys platforms, and then real-world use feeds back into the research.
Definitely. And that emphasis on responsible development principles, driven by voices like Salehi's, seems to be gaining crucial traction as these systems become more capable and widespread. The overall market trend is clear: rapid platformization and aggressive push into various industries, but also a necessary caution emerging around potential vendor lock-in as companies choose which ecosystem to bet on. And that disruption of business models moving towards per-task or value-based pricing is a really significant undercurrent.
Okay, so given all this rapid progress and huge potential, What are the main roadblocks? What are the big challenges and limitations the field is still wrestling with?
The sources lay out quite a few significant technical hurdles. Reliability and predictability are still major concerns. Because the underlying models, the LLMs, are probabilistic, the agent's behavior isn't always guaranteed. It can be non-deterministic, which makes debugging incredibly difficult.
That hallucinating intern problem again.
Yeah.
Hard to know why it went off the rails.
Exactly. They also still struggle with really effective long-term planning and maintaining context over extended complex interactions. Often, they need very precise, carefully crafted initial instructions to succeed.
Are they robust in using tools?
That's another challenge mentioned: fragile tool use. An agent might be trained to use a specific API or website. If that API changes slightly or the website layout is updated, the agent might just break, whereas a human could likely adapt easily. Maintaining state consistently over time and recovering gracefully if something fails mid-task are also really hard technical problems.
Just figuring out if they're actually working well.
Right. Evaluation is tricky. How do you reliably measure if an agent is truly effective and robust across different situations, or if it just got lucky on a few test cases? There's definitely a gap identified between the level of autonomy people want from agents and what's currently achievable with high reliability, especially for critical enterprise tasks.
So this basically demands entirely new approaches to software engineering, doesn't it? New ways to build, test, and manage these kinds of systems.
Precisely. New methodologies, new tools, especially for explainability, XAI, are essential just to get a handle on building and maintaining these things effectively.
Okay, beyond the purely technical hurdles, what about the broader ethical and societal challenges? The sources seem to suggest agent autonomy amplifies existing issues.
It really does. Balancing that desirable autonomy with the need for appropriate human oversight is a constant tightrope walk. Then there's the thorny issue of accountability. If a fully autonomous agent makes a mistake or causes harm, who is legally or ethically responsible? The developer, the owner, the agent itself. It creates a potential liability vacuum.
That's a big one.
Huge. Bias is another major concern. If the data used to train the agent, or the underlying LLM, contains historical biases, gender, racial, whatever, the agent can perpetuate or even amplify those biases in its decisions or actions, leading to unfair outcomes.
And the potential for misuse. Does autonomy make that worse?
The risks are definitely magnified. More capable, autonomous agents could potentially be used for more sophisticated cyber attacks, generating highly convincing misinformation or deepfakes at scale, or even coordinating harmful activities. The increased power and independence raise the stakes considerably.
And of course, the impact on jobs.
Yes, the concern about job displacement is real, as with any major automation wave. It underscores the critical need for proactive workforce planning, reskilling initiatives, and thinking about societal safety nets. The sources generally frame these not as entirely new problems created by agentic AI, but as existing societal and ethical challenges that are intensified, made more complex, by the introduction of autonomous systems. Stronger guardrails are needed.
And data privacy and security must be a massive headache, especially if agents need access across many different systems.
Oh, absolutely. The risk landscape expands significantly. Just the fact that agents often need broad access to various data sources and tools inherently increases the potential attack surface for malicious actors.
More doors to try and break down.
Exactly. There's also the specific concern about data persistence sensitive information that an agent processes might inadvertently become embedded within the parameters of the underlying LLM during its ongoing learning or fine-tuning process. Hard to track, hard to delete.
And specific attacks targeting agents.
Yes. Things like prompt injection, tricking the agent by embedding malicious instructions within seemingly harmless inputs, or adversarial attacks designed specifically to fool the agent's perception or decision-making. These are serious threats that require new kinds of defenses.
So robust security and privacy aren't just nice-to-haves, they're absolutely fundamental baseline requirements for deploying these systems.
Completely non-negotiable, especially in enterprise or sensitive contexts. The sources stress mitigation strategies. Start small, maybe in sandboxed environments. Containerize access to sensitive data. Use data anonymization techniques like stripping out personally identifiable information, PII, wherever possible. Implement robust security monitoring and access controls specifically tailored for AI systems. And ensure strict compliance with data privacy regulations like GDPR or CCPA. The expanded attack surface means traditional cybersecurity thinking needs to evolve.
Okay, so given this complex mix of incredible potential and significant challenges, What are the big open questions that researchers and developers are still trying to crack?
Well, fundamentally, it's about making agents truly useful, reliable, and safe in messy, unpredictable real-world scenarios. That's the overarching goal. Specific areas include improving their long-term memory and ability to manage context over extended tasks.
Getting beyond that short attention span.
Right. Enabling them to handle truly complex, open-ended tasks that require deep reasoning and planning, not just following relatively constrained workflows. Developing more robust reasoning capabilities that are less prone to making things up or getting stuck in loops, really tackling those hallucinations. Ensuring they are properly grounded in factual knowledge and can reliably interact with complex data formats, like autonomously understanding and manipulating spreadsheets, which is still surprisingly hard. And a very practical one, optimizing their cost effectiveness. Right now, making lots of calls to powerful LLMs can get very expensive very quickly.
So lots of fundamental work still needed. How are organizations trying to approach building these systems responsibly, given all those challenges we just discussed? What strategies are emerging?
The sources consistently highlight several key strategies for responsible development. First, implementing clear governance frameworks and ethical guidelines right from the start, not as an afterthought.
Setting the rules of the road early.
Exactly. Second, prioritizing transparency and explainability using XAI techniques to make the agent's decision-making process as understandable as possible, at least to auditors or developers. Third, ensuring meaningful human oversight, with clear guidelines for when and how humans should intervene or review agent actions.
Keeping humans in the loop.
Yes, especially for high-stakes decisions. Fourth, establishing clear accountability structures defining who is responsible for the agent's behavior and outcomes. Fifth, investing heavily in enhanced security measures specifically designed for the unique risks of agentic systems. Sixth, focusing on AI education and workforce transition programs to help people understand, collaborate with, and adapt to these new systems. Seventh, building in robust guardrails and fail-safe mechanisms to detect and prevent harmful or unintended actions. And finally, perhaps overarching all of this, adopting a human-centered ethos.
Human-centered ethos. What does that mean in practice?
It means prioritizing things like user control, privacy, safety, designing agents to recognize ambiguity or uncertainty and explicitly escalate those situations to a human rather than just guessing, building systems that genuinely augment human capabilities, not just automate tasks blindly.
What really stands out from that list is how intertwined the technical and the ethical or responsible aspects are.
Completely. They're not separate issues. For example, improving technical explainability, XAI, directly enables better accountability. Building agents with better context understanding and grounding can help mitigate certain types of bias that arise from misinterpreting data. It's not just about building more powerful AI, it's about building better AI, safer, more reliable, aligned with human values right from the foundations.
So, to bring this all back home for you, the listener, Agentic AI clearly isn't just some far-off future concept. It's a profound technological shift that is happening right now, and it's already impacting multiple industries, as we've heard.
And the sources really lay out some critical strategic imperatives for anyone navigating this. You need to start evaluating seriously where and how agentic AI could bring tangible value in your specific context. Maybe that means starting small, running pilot programs in contained, lower-risk areas first.
And prioritizing that human-in-the-loop design seems absolutely essential, especially now, for building trust and ensuring safety with these still evolving semi-autonomous systems.
Absolutely. And on the technical side, building robust, flexible architectures, think modular, scalable, interoperable, maybe leveraging things like knowledge graphs for that grounded reasoning that's going to be key for successfully deploying these systems at any significant scale.
Plus, investing in your people, reskilling, training, preparing your workforce to collaborate effectively with these new AI systems is vital. You can't just drop this technology in. People need to adapt to.
And establishing strong governance, ethical guidelines, and oversight frameworks early on isn't just good practice. It's necessary for navigating the complexities around accountability, potential bias, security risks, all the things we've discussed.
And perhaps most importantly, committing to continuous learning and adaptation, right? Because this field is just moving at such a breakneck pace. What's state-of-the-art today might be outdated in 6 months.
You have to stay informed. And it's clear, listening to the sources, that the dominant narrative isn't really about technology simply replacing humans wholesale. It's much more nuanced. It's about optimizing complex workflows, augmenting human capabilities, and integrating these increasingly sophisticated, valuable digital contributors into the very fabric of how work gets done.
Agentic AI seems undeniably poised to redefine work, productivity, and economic value creation in fundamental ways.
Yeah.
So the critical question, maybe the final thought for you and your organization, isn't if this wave will arrive. It's already here. The real question is how swiftly, how thoughtfully, and how effectively you will adapt and harness its power.
Yeah. Where could integrating these sophisticated digital contributors truly make the biggest, most positive impact in your world, starting right now? That's the question to mull over.
A powerful question indeed. Thanks for joining us for this deep dive into the fast-moving world of agentic AI.